promised you that section 4.4 was just going to be a quick diversion from trigonometry because we already are back looking at how this relates to trig. So ultimately, we're going to be looking at vectors, and we need to learn how to add them and subtract them in a way that doesn't rely on us just drawing them to scale, because it's pretty hard to draw those vectors to scale and know what the value would be. So we're going to start by doing what's called a resolving of a vector into its components. So I want you to look at this vector A in our drawing. So this vector A is, you can consider this as having an X direction and having a Y direction. Now you can have a positive X if you go in the positive direction, or a negative X if it's in the negative axis direction. Basically, positive is to the right, negative is to the left. And then the Y direction is positive when it's going up, negative when going down. So this particular vector, if it has a magnitude of 200, and or not 200, 20.0, and we want to resolve it, well, what we ultimately need to do is think of this as a right triangle. So if I draw this as a right triangle, we have our X, our Y, and then that 20 is the hypotenuse. So how would we solve this? How would we find X? Well, that's the adjacent over the hypotenuse for this given angle 56 degrees. Remember, our vectors have to have magnitude and direction, so we had a magnitude of 20, but we also see that it's in this 56 degree direction. So how would we set that up? Well, cosine of 56 degrees equals X over our hypotenuse of 20. Let me change color. So we multiply by 20, and our X component is 20 times the cosine of 56. Well, how would we get Y? Well, now Y is on the opposite side, and so sine of an angle gives us the opposite over the hypotenuse. We can multiply by that hypotenuse, 20, and we see that our Y component needs to be 20 times the sine of 56. And that's always going to be how we find the components of any given vector. It's simply going to be the magnitude of the vector times cosine of the angle for your X component or your horizontal component, and then the vertical component is going to be the magnitude times the sine of the angle. As to finish up our example 1, we would say that AX or VX, whatever it's named, in this case it's vector A, is going to be equal to whatever 20 times cosine of 56, and that is 11.2. And then 20 times sine of 56 gives us our Y component, and that's 16.58 or 16.6. We can do some application problems here. And this first one, we can look at a rocket that is directed with this vector V. And we see that it's at this 23.5 degree angle down. So how would we think of this in terms of our trig values? Well, one thing that we could ultimately do is think about this angle as actually being negative 23.5. Since we went in that clockwise position, that's a negative angle. And so if we want to find our X component, then we just need to take our magnitude, which in this case is 350, and multiply this by our cosine of this angle. And that gives us 350 times cosine of negative 23.5. We have a horizontal component of, we'll make that 321. It's 320.97, so we'll make that 321 kilometers. And then our Y component will be 350 times the sine of negative 23.5. And that gives us negative 139.6 kilometers. So I want you to notice here, if you look at the direction of this, it was going to the right and down, so it should make sense that the horizontal was a positive value and the vertical was a negative value. Let's do one more here. Example 3, we're looking at the stress of a ceiling joint caused by snow on a roof. And so here, in order to figure out what's going on in this particular case, we would need to resolve this force vector where we had a 13.4 pound force at this 210 degree angle. And if we want to get the horizontal and vertical components, then what we need to do is first make sure that 210 is the appropriate way to discuss this, and it is. That's going in that counterclockwise position, so it should be positive. And our Rx will be 13.4 times the cosine of 210 degrees. We're looking at negative 11.6 pounds, which makes sense. That's in the left direction. And then our y component will be 13.4 times the sine of 210 degrees. And again, we get negative, and that also makes sense because it's in the down direction to get this overall resulting vector.